Okay, let's talk about slope. When we're talking about slope, we are talking about the steepness of a line. So slope is a measure of the steepness of a graph. So slope is a measure of the steepness of a line on a graph. So think of a mountain, how steep the mountain is. The steeper it is, the faster it inclines. The less steep that it is, it inclines slowly, right? So we're going to do the rise divided by the run. Rise is the vertical change when the slope of a line is expressed as the ratio of rise over run. Okay? Or writing it out so you know what you wrote, rise over run. Okay, run is the horizontal change. Think about when you run, you're running horizontally, right? When you rise up out of the chair, that's a vertical change. You were sitting down, now you're standing up. When you rise, that's a vertical change, okay? When the slope of a line is represented as the ratio rise over run, or rise over run, okay? Over here, I just want to put change in y over change in x so that you know, okay? We also call this the rate of change. The rate of change is a ratio that compares the amount of change in a dependent variable to the amount of change in the independent variable. And this should sound familiar to you. This should sound exactly like what we did a few pages back when we talked about our notes for graphing linear equations. I'm sorry, not graphing linear equations, when we talked about the, right here, solving proportions. So rate of change, a ratio that compares the amount of change in a dependent variable to the amount of change in the independent variable. Same thing here, rate of change. Okay, so this is not new material. Slope is equal to the change in y values over the change in x values, which we call rise over run, and we notate that with the variable m. Okay, you should have also been given a piece of paper with some graphs, and so we're going to sort these graphs into positive, negative, undefined, and zero. Okay, so a positive graph is increasing from left to right. So for example, if we turn the paper this way, the graph is increasing from left to right. That's the thing about these graphs. If you turn them the right direction, then they will work. So increasing from left to right is your positive slope. Make sure when you glue it down, you have it in the right direction so that it's increasing from left to right. Think about going up a hill, okay? Or going up a ski lift. If you've ever been skiing, it's really fun to get on the ski lift and it's exciting the first time. It's a very positive thing going up that hill, okay? A negative slope is the opposite of a positive slope, obviously, so it's going to be going down the hill. So when you glue that on, make sure you're going down from left to right. We always read graphs from left to right, so we're going down. For me, Miss Bernard, I'm not very athletic, so it was really fun to go up the ski lift the first time that I ever skied, but it was terrifying and a horrible experience for me to come down because I fell constantly. Okay, when we talk about a zero slope, in order for a fraction to equal 0, the numerator has to be 0, right? So if the numerator is 0, that's the vertical rise is 0, which means that I'm not increasing vertically, so that's going to be your horizontal line. Okay, so it's going to look like this. And then the same thing, undefined. For a fraction to be undefined, the denominator has to be 0, and that means there's no horizontal change, and so we are looking for a vertical line. And you can't see those really well, so let me highlight them for you. Okay, all right, and that is that page.